Okay, welcome. This is a video to help you learn the distinction between direct relationships and inverse relationships. You are going to hear about this throughout the entire year in physics. And the simplest way I can explain it, any direct relationship is a relationship between two variables such that an increase in one variable corresponds to an increase in the other variable. In other words, increasing the x variable is proportionate to increasing the y variable. Examples, real simple. If I eat more and more food, I gain more and more weight. Inverse relationships, just the opposite. An increase in one variable corresponds to a decrease in the other variable. So anytime you have a two-variable relationship, and you can recognize that by increasing one variable, say the x variable, that will directly correspond to a decrease in the y variable. So while maybe if I eat more food, I gain more weight, that's a direct relationship, but if I exercise more, as my x variable, then I can lose more weight. An increase in exercise could correspond to a decrease in weight. Inverse relationship, very generic. And if you apply these examples to math and physics, you see them all the time. So I'm going to give you an example in math first. Let's say you have a square, and you're looking at the side length of a square and its perimeter. So if it has a length of 1, then the perimeter is 4. The perimeter is 4 times the length of the square. If it has a length of 2, the perimeter, therefore, is 8. Length of 3, the perimeter is 12. Very simple. As you double the length, you double the perimeter. As you triple the length, you triple the perimeter. And if you graph that data, you could quickly find a relationship that has a positive slope, a linear trend relationship, showing a direct correspondence between the two variables. You will always see a trend in a direct relationship that points upward with a positive slope. Another good example, mass and weight. This is a good physics example. You're going to learn that as you increase your mass, you increase your weight. So if, let's say, my daughter is all of 10 kilograms, she weighs about 22 pounds. She suddenly increases her mass up to about 20 kilograms, well, she'll weigh about 44 pounds. She gets up to 30 kilograms, she'll triple her weight. She'll get up to 66 pounds. So the more mass you have, the more weight. Again, direct relationship. Doubling the mass doubles the weight. Tripling the mass triples the weight. You see this trend graphically. It shows a positive slope. All direct relationships will show any increase in the x variable corresponds to an increase in the y variable. Now, inverse relationships are a little tricky. So let's take a volume problem where maybe you've studied density, which is the relationship between the amount of mass per unit volume. And anytime you have an inverse relationship, an increase in one variable, say, for example, volume, as volume gets larger and larger because that variable is in the denominator, you'll notice the density is going to get smaller. And for this example, let's just say you're shipping a bunch of oranges in boxes. Okay, so I'm just going to call it a simple example. You want to compare the volume of the box, the volume of the container X, to the density of oranges per unit volume. So if I have, I don't know, 20 oranges packed into a small box that is, let's say, 1 gallon, and you could quickly see that, oh, okay, I have this, 20 oranges per gallon. But if I double the volume of that box, suddenly I've got 20 oranges, and the same 20 oranges in 2 gallons. So now my density drops. By doubling the volume, I have half the density. If I triple the volume of the box, a 3-gallon box shipping those 20 gallons, this will reduce to 1/3 of its original value, which is about 6.7. If you quadruple it, it reduces to 1/4 of its value. And so if you start to graph this trend, you start to realize for a smaller volume, you have a much greater density. And as the volume gets larger, the density, double the volume, the density gets cut in half. And if you quadruple the volume, the density gets cut down to 1/4, and you get a different trend graphically. So graphically, an inverse relationship will always show a trend that has a negative downward slope. as opposed to a direct relationship with an upward positive slope. Another good example in physics is the mass of a vehicle and its acceleration. So let's just say you're pulling a cart, pulling a wagon with some friends to the park. And nobody on the wagon, very small mass, and you're pulling it at some acceleration rate. Let's just say 12 units of acceleration. Suddenly a friend jumps in the wagon, and the mass is doubled. Okay? Once somebody jumps in that wagon, you're pulling it, you're going to slow down. You're going to lose some acceleration. Say a second friend jumps in the wagon, so now you got triple the total mass of the wagon. Once again, be heavier, harder to pull, your acceleration is going to get reduced. All of a sudden, 4 people jump in the wagon, and it's become very difficult to accelerate. And once again, you can see that an increase in mass, as you're pulling this wagon, will correspond to a decrease in acceleration. So you get an inverse relationship. All inverse relationships will have some sort of trend graphically that points downhill to the right with the negative slope, just like you see here.